Hi, I'm Bob. Welcome back to the solutions to the exercises in the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition. We will solve the problems related to repeated dynamic games today. If the tutorial helps, please subscribe to my YouTube channel. Thank you. Let's find answers to exercise 2.1. In a repeated game, how does the outcome differ if firms know that the game will be repeated indefinitely or repeated a known finite number of times, or repeated a finite number of times but the firms are unsure as to which period will the last period? If it is a repeated game and the game will continue forever, then the firms can use a trigger strategy to get a collusive outcome, so that both firms can attain a higher profit than in a single period static game. For example, in an indefinitely repeated prisoner's dilemma game, player 1 can use a trigger strategy by refusing to confess in the first period. If player 2 does not confess either, player 1 continues to remain silent each time they get arrested, and therefore they maximize their joint payoffs in the cooperative outcome in each period. If player 2 defects from cooperation, the next time they are arrested, player 1 will confess, and player 2 will suffer from a longer imprisonment. Although player 2 receives a higher payoff in the first period, he will suffer low payoffs in the future. If he values future payoffs, he will cooperate with player 1 from the first period. Thus, if the game is played multiple times without ending, a cooperative outcome may occur in each period. In Part C, if the game repeated a finite number of times but the players are unaware of when the last period is, then it is like an indefinitely repeated game, and a cooperative outcome is likely to happen in each period. However, if in Part B the players know when the last period is, then they will defect in the last period because there will be no punishment after that period. As a result, the last period is like a single period game, and both players will deviate from cooperation. Knowing that they will cheat in the last period, they will also cheat in the second to last period because no additional punishment can be imposed. By the same reasoning, the players will deviate from cooperation from the first period, and collusion is unlikely to happen. That is to say, the one-period static game Nash equilibrium occurs in each period in the finite repetition game. Let's solve exercise 2.2. The allies play the game in table 30.1 repeatedly. What happens if the players know the game will last 5 periods? What happens if they repeat the game indefinitely, but one or both firms care only about current profit? If the game will last 5 periods, the last period will be like a single period game because there will be no punishment for deviation in the future. That makes the 4th period a single period game too, because no additional punishment will be imposed for deviation. For the same reason, the first period will be a single period game and no cooperation will happen. The single period static game Nash equilibrium occurs in each of the 5 periods. If the firm cares only about current profit, the future punishment or benefit will not affect the firm's decisions. It makes any punishment or benefit irrelevant to the game. The players behave like in the single period static game. As a result, the single period static game Nash equilibrium occurs in each period of the indefinitely repeated game. Let's go to exercise 2.3. You and your best friend swear that if either of you reveals the other person's secrets, that person will never speak to you again. How is this scenario like the repeated games described in this chapter? Discuss the circumstances under which this oath will result in neither of you revealing the other's secrets. Let's first consider the Nash equilibrium if it is a single period static game. We use the best response approach and find the Nash equilibrium. Each player reveals her friend's secrets. It is a prisoner's dilemma game. If they cooperate and do not reveal secrets, then each can have a higher payoff. Next, if the game is repeated indefinitely, then the player can use the trigger strategy to get a cooperative outcome. The trigger strategy is that player 1 does not reveal player 2's secrets unless player 2 reveals player 1's secrets first. In that case, player 1 will also reveal player 2's secrets. For player 2, if she cooperates, that is, she does not reveal her friend's secrets forever, her expected payoff for the indefinitely repeated game is as follows. The parameter R is the player's depreciation rate. A higher R indicates a lower present value for future payoffs. Using the formula for the sum of an infinite geometric series, we simplify the expected payoff as 1 over R. If player 2 defects in the first period, that is, she reveals her friend's secrets, her expected payoff is as follows. Her payoff in the first period becomes higher, but her sequential payoffs in the future periods become lower. The depreciation rate R translates future payoffs into present values. For player 2 to cooperate, in other words, for the trigger strategy to be successful, the expected payoff from cooperation should be higher than the expected payoff from deviation. We obtain the condition that R is smaller than 2/3. It implies that if the depreciation rate is small enough, or the player cares about future payoffs, then cooperation is likely to occur. Therefore, if the game is repeated for indefinite periods and you care about future payoffs, neither of you will reveal your friend's secrets. Generally speaking, the condition for cooperation or collusion in an indefinite repetition game involves the relative payoffs for each combination of the strategies and the depreciation rate. Thank you so much for watching this video and subscribing to my YouTube channel. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.